Hello everyone. In this video, I'm going to show you how to complete the milestone 1 machine learning algorithm. Okay, as usual, we log on to the Azure portal. This step you are familiar already. Use the provided credential, username, and the password. Okay, this experiment will be using the custom dataset. So we prepare to download dataset first. From the tiny URL. Okay, we're going to do this later when we provision the Azure Machine Learning Workspace. So now the first thing we have to do is to create the Azure Machine Learning Workspace. Okay, so create. For the resource group, I'm going to create the Milestone1 RG, and then the workspace MLW Milestone1. Then the rest follow the default setting. Okay, click here. Okay, this take a while. Then I will use the time to prepare the data set. Go to the milestone folder, then download this data set. Okay, so yep, extract this. Okay, we're going to use this student performance factors CSV, the data set. Let's have a quick look. We have the Excel. Okay, so students performance factor. This downloaded from I think Kaggle. Let's have a look if we can find more, because sometimes we need to get the explanation about the column. Okay, so student performance factor dataset. Okay, student performance dataset. Okay, here you go. Okay, yeah, so this is the dataset. We can see the code. Okay, where data card student. Okay, home dataset. Wait, license the column. This one. Okay, never mind. Just look at the Excel. So we have the number of hours study, and then after that the parental control, access to the what is this? We have to yep access to resources, extracurricular, and so on. In one of the column is the sleep hours. So sleeping hour of the students. 7, 8, 7. Yeah, okay. So the experiment, we're going to train the machine learning model to predict these sleep hours by making use the this column. Some of the column are numeric, like exam score, study physical interaction, then study extracurricular, and some are the category like a low, medium, yeah? Parental control, parental involvement, access to resources. So we will be using these features to predict the sleep hours. Okay, let me keep this open. Then look at here. Okay, the workspace already completed. Yeah. Okay, now I'm going to launch Studio. Okay, before that, you may want to look at uh, the screenshot. What screenshot we need to collect? Sorry. Okay, milestone regression. Okay, looks like as usual. We set up the Azure Machine Learning workspace, create a compute instance, after that create the data set, after that create the pipeline, and then after that train the model, after that yeah, compare the score. Yes, so I think every step we just create one screenshot should be okay. Yeah. Or yeah, because this is going to be used as a final project report, so you can take the more screenshot. Yeah. But number one, number two, number three, creating dataset is you did this many times. Yeah, so just one or two screenshot acceptable. The more in the this create a pipeline, then after that running job, yeah, then compare the model. Okay, I will bring this to the other screen. Okay, or maybe later I prepare the template. Let me consider. Yeah. If needed, then I will create the template for you to place the screenshot for the milestone one. Okay, let's continue. Yep, here you go. Launch the studio. After that, we're going to create a compute instance. Okay, so new compute instance. Okay, give the name. Okay, Ryan CMPI. Okay, like this. No need to use the test. CPU, the cheapest. Then next, yeah. If not, if idle, then shut down. If idle for 30 minutes, yeah. Next. No need to change anything. Then just review and create. Okay, we just leave this to run, yeah, as usual. Click the data, then after that create the data set. Okay, so in the create data set, you're going to configure creating the data set. Data set name is the student performance. Okay, and then description. Also just put the student performance. The type is tabular. Okay, then after that next, from the local file, next, then use the blob. Yeah, after that next, you're going to upload the files, and then yeah, in the download this one, student performance. Yeah, override this already exists, optional. Yeah. Then next, so we have this data validated. Yeah. Okay, so nothing you need to change, just click next. After that next again, then create. Yeah. Okay, so creating the student performance data set. Okay, so you can create a screenshot for this if you want to pay to be put in the yeah, for you to put in the milestone one result. Yeah. Okay, then the next step is to create a pipeline. Yeah, so go to the designer, and then create a new pipeline. Okay, the name is student performance prediction. Okay, so just replace this, save. After that in data, student performance. Okay, after that we're going to add the clean missing data in the component. Okay, in the clean missing data, you're going to select all the column. Okay, after that you're going to remove the entire row. Okay, so this is a simple like this. Then after that we add the normalize the data. Okay, for the column you want to normalize the transformation as score, include the numeric columns. Okay, this one. Okay, so edit the column. Okay, include the column name. Yeah, this one. Oh, sorry, I need to copy paste. Okay, our study: attendance, sleep hours, previous score, tutoring sessions, physical activity, and exam score. Save it. Yeah, then after that use the 0 for constants, no explanation, so just leave it. Okay, after that save it, close, and then edit metadata. Okay, in the edit metadata, then you're going to include this column. Okay, let me edit first before I put there, because there is a typo mistake or extra space that we need to remove. Okay, so here between the learning and disabilities, there is a extra space that you have to remove, otherwise then you will get an error. Okay, here you go. Yeah, so copy, then after that edit the column, so here, then enter. Okay, so looks like all good, the column. Click save it. Okay, other than this column setting, then data type is unchanged, categorical is make category, and then the fields is unchanged, and there is no renaming the column name, so leave it like this. Yeah, click save. And then you're going to convert to indicator value. Okay, convert to indicator value. Okay, convert categorical value in a columns to indicator value. Okay, here you go. Then in the convert indicator value, we use the same column name like this. Okay, so the disability, learning disability already removed the extra space. Okay, and then enable the override true. Okay, after that next, to split the data. Okay, after that follow the setting of the split data. So we're going to follow the split row with 7 and 30%, 70 for training, 30% for the testing, and randomize true, random seed 0, and then stratified true. Okay, guys, you will get the question from me. What is the meaning of the stratified split true, and then provide the stratified column? Yeah, okay. So what is the impact of enabling this? Okay, so we have split. Now we're going to populate the training model. Okay, so we're going to choose the two algorithm, the neural network and boosted decision tree. Okay, neural network regression and boosted decision tree regression. Okay, then we're going to use the tune hyperparameter model hyperparameter. Okay, one more. Yep. Okay, then this is the neural network. Yeah, so we don't change anything for this. Yep, and then we just configure the tune model hyperparameter. Okay, so in here one by one, choose the entire grid, and then for the regression we use the mean absolute error, and then for the column label sleep hours. Be careful the typo, so lowercase uppercase must follow. Okay, so this change the setting of this one also, entire grid. After that mean absolute error, and then the column is sleep hours. Okay, okay, yep. Now we're going to add the score model and then evaluate model. Okay, so we bring this first here, the untrained model, and then the dataset. Okay, score the model. Okay, so here the output of this train the best. Okay, and the testing dataset from the right of the split the data. Okay, after that add the evaluate the model. We're going to compare this. Okay, left is this the neural network, and then this logistic regression go to the right side. Okay, yep, neural network then boosted. So the top is the neural network, below is the boosted decision tree. Okay, so save, don't forget, and then after that configure and submit. So create a new, the name is AML project. Okay, display name is the milestone1. Okay, then review and submit. Before that we provide the runtime, compute instance, and the one that we just now created, Ryan CMPI. Okay, then submit. Okay, then yep, so we're going to monitor this in the job. Okay, let's see if there is any error. We need to fix it. Looks like just started. Okay, so we wait for a while for this to complete. Yeah. Okay, yeah, so slowly. perform the cleaning first, the missing data. After that, normalize, edit, then convert indicator value, which then continue with splitting the data. Okay, let me check if there is anything else to do. No, yeah. After this, we're going to compare the metrics. Yep. Okay, finish with the clean missing data, and then continue with normalize. Okay, let's look at the original data. There are 22 columns. Okay, if you look at the Excel, 14,000, yeah, 14,000, and then 22 column, 40,000 rows. Is a quick profile generated 10,000. Okay, now if you compare with this after clean missing data, okay, yeah, so only left 6,000 plus. So many some of the row are not complete. Yeah, there are some missing value, so we remove entire row. From the 14,000 become 6,000 only. Yeah. After that, normalize using the Z-score. Yeah, so the numeric value is changed to the value between standard deviation. Yeah, okay, so change already. Okay, actually the sleep hours, because this column is the one that we're going to predict, yeah, the label, so this should not be normalized. Yeah, other numeric column can be normalized, but this should not be normalized. Yeah, okay, never mind, later we going to modify a little bit. Okay, so now is tuning the model hyperparameter. Okay, we just wait for. Okay, while waiting, we go to the designer, we make some adjustment in the normalize the data. So the sleep hours shouldn't be included. Yeah, the sleep hours, we don't normalize the data that we're going to predict. Okay, close, and after that edit metadata. No, we don't have the sleep hours because it's the numeric value, so nothing to change here. Convert indicator value also no need. Yeah, we don't have the sleep hours here. Okay, only that just now in the normalized data. Okay, let's go back to the jobs. Confirm. Yep. Okay, so let's have a look. Still doing the training. Okay, wait for a while. Did we save just now? Let's check again. uh, the designer, normalize, yeah. Okay. Ah, didn't change. Okay, save it there, then close. Okay. Ah, okay, so this part is on the top, the neural network completed, and then we're going to tune model complete with the boosted decision tree. Okay, score the model, then let's score it. Okay, almost done. Yep, evaluate the model. Yep. Okay, so done. We check the value, preview the data, the result. Okay, yeah, so we found that on the top is a neural network, and below is a boosted decision tree. So on the below, the error is lower. Yeah, in overall the error is lower, and the coefficient determination is close to 0. Okay, so if you compare the two machine learning algorithm, the below or the boosted decision tree is better than the neural network. But overall, because the coefficient determination is negative, close to 0, that means the model is actually not doing well. Yeah, poor uh, model. Yeah, okay. So remember last time I show you the answer about the explanation how if the machine learning performance is the coefficient determination is close to 0. Yeah. Okay. One moment. Yeah, here you go. Yep. So why coefficient determinations is negative near to 0? Yeah. Negative coefficient determination, especially one close to 0, indicate that your statistical model is performing very poorly and is essentially explaining less than 0% of the variability in your data, meaning the fitted line is worse than simply using the mean as a prediction for the all data points. Yeah, this usually happen when the model is significantly underfitted or when there is a major problem with the chosen regression method for the dataset. Okay. Yeah. So now I'm going to so your milestone one is done, but I'm going to explore more, yeah, regarding this. Yeah. So how about if I choose two other algorithm? Yeah, can we do that? Yeah, of course. Yeah. So we uh, we have a few others regression. Yeah, go to the designer. Okay, so minimize a bit. Yep. Okay, a bit again. Okay, good. Okay, so let's have a look at the regression. What other algorithm we have? Yeah, linear regression. Yeah, then Poisson regression, decision forest. Yeah, this one is a classification. Don't use, yeah, because two-class logistic regression is the uh, classification. Okay, I'm going to add the linear regression. Okay, then after that also the decision forest. And I'm not going to use the tune model hyperparameter, but just a normal train the model. Okay, and when we train the model, label column is sleep hours. Okay, after that the model explanation we make it true, save it, yeah, close, then one more. Can I copy? Then yeah, can copy paste, yeah, train the model. Okay, yep, sleep hours true. Okay, then we copy the score model twice. Okay, then evaluate the model. Okay, so the untrained model go to the here the left side, then the training dataset come to this part. Okay, the same thing with this below, then training dataset move here. Okay, then the train model is coming to here. Then the testing dataset come to here. Okay, then after that score the dataset go to here. Then this one, yeah. So on the top evaluate model, this part is linear regression, and this is a decision forest. So save, then configure submit, select the existing. Okay, then after that review and submit. Okay, so we make two changes. Yeah, the tune model hyperparameter replaced with the normal train model, and then the algorithm we choose the linear regression and push the decision tree. Okay, go to the jobs. Okay, so looks the latest one. Okay, yeah, still doing. We make changes in a normalized data, so this repeated. So now the sleep hours is not normalized. Okay, yeah, sleep hours is maintain the original value. Okay, we wait for a while. Yeah, currently converting to the indicator value. Okay, just wait for a while. Yep. Okay. Split the data. Okay, wait for a while. Yep. So now parallelly perform the tune, train, yeah, with the different algorithm. Wait for a while. Yeah, so the lab need to be extended 30 minutes. Okay, everyone, uh, still ongoing. Maybe later, yeah, I'm going to create another regression, but changing, yeah. The prediction is we don't predict the sleep hours, but we will predict the exam score, yeah. So we create a model to predict the exam score, and the prediction is based on the other features like sleep hours. Then after that, the yeah, so all other columns in the students performance dataset. Okay, almost done. Yeah, so maybe in the next 2-3 minutes this should be completed already. Only left with the boosted decision tree regression. Okay, almost. Yeah, just wait for a while. Yep, so this done, then we can have a look at this. Just wait a while. This won't take long because only combining the two score model. Yep. Okay, let's evaluate the review the data. Hmm. Uh, the error is even higher, yeah. So not better than before. This one is also slightly far from zero. So just know the error is in general is about 0 point something. Yeah. So these two are not better. Okay, so if you open the this one, okay, not doing finish yet, still scoring. Okay, yep, almost done. Yeah, so we found out that this data is not good. So could be meaning that the sleep hours actually cannot be predicted by those other column. Yeah, the model that generated is very poor. So it's like very close, or it's better to just predict by the average of the sleep hours compared to the using the machine learning model. Okay, wait for a while. Yep, so preview the data, then evaluation result. Okay, oh okay, I think I know why. Because just now we make some changes on the the that's not the sleeping hours. Yeah, so the sleeping hours we do not normalize. Okay, yeah, actually when we normalize the sleeping hours, then the error is better. This is okay, 114 146. Yeah, this one is okay, this is higher. Yeah, okay, so still this one is better. Okay, I'm going to go back to the designer, then after that I'm going to clone this, but this time I will predict the exam score. Yeah, so here in the Excel we have the where is it, the column, yeah, exam score, yeah, exam underscore score. Okay, so we go back here, yep, so go to the, yes, okay, so edit the column, then after that we remove the exam score, but we add the exam, there's no sleep hours. Okay, normalize. Yeah, then after that here in the train the June model hyperparameter, then we change this to the exam score. We want to predict this. Okay, okay, this one is an extra step that not in the milestone instruction. Okay, the rest are the same. Yeah, we rename this student performance prediction. Okay, exam score. Yep, save it. Then after that, submit. Okay, yep, select existing, then submit. Okay, submit pipeline succeeded. Then go to the jobs. Okay, so this one running. Yep, mostly we need to redo everything because we changed the column. Okay, yep. Okay, so still doing. Edit metadata. Okay, so in the meantime, while waiting, then I have collected a few questions which I might ask you. Okay, so questions to prepare. Okay, what the differences between n-gram and feature sensing? Okay, okay, what the difference between is that the correct limit decision? Okay, later I check the grammar. If the feature hashing is configured with the 2 grams and 10 bits, how many features will be created. Okay, yeah, then just now explain when the meaning of in the milestone 1. Okay, 4 question, yeah. Yeah, so still doing this. Start scoring the model. Okay, this is a few questions that I prepare to answer these questions during the presentation. Okay, later we'll add more. Yeah, almost. Okay, this one done. Yeah, so preview the data and then evaluation result. Why is like this? Preview the data. Okay. Okay, so you see the coefficient determination is good. Yeah, so meaning that the sleeping hours is not good to be predicted by the others, but for the exam score, yeah, this not bad. Yeah, the coefficient determination. Okay, and the RMSE and also the mean absolute error is not bad. Yeah, like the exam score is 76, 75. Yeah, so plus minus 1.84, 2.4, meaning not too bad. Yeah, so we can see that this data is good to predict the column like exam score, yeah, but not the sleep hours. Okay, and how about this one? Maybe we can see later, yeah, whether this is better than this. Yeah, just now was 0.7 something. Okay, yep. So right click, then preview the data. Okay, then okay, this one is even better. Yeah, even better. And this one is I think 0.75 and the RMSE 0.5, 1.8 and 0.5. Okay, so this one. Yeah, so this linear regression is better. Yeah, and then this one is a boosted decision tree is better, right? Now if you want to compare these two, yeah, then I would like to add one more directly in the designer. Okay, so here I copy again the evaluate model. Just now we want to compare between the boosted decision tree here and the linear regression. Okay, yeah, so then after that save it. Okay, so this one is between the boosted decision tree and the linear regression. So configure, submit, yeah. Okay, yeah, I think this one will be very fast because only comparing the evaluate the model only. Yes, okay, come here. Okay, so still doing. Yeah, just wait for a while. Will not be long because it's only comparing the score. The previous training model, the result can be reused. Okay, on the top is the boosted decision tree, and then below is the linear regression. Okay, which one do you think error better? Yeah, looks like this one. Yeah, 0.4, 0.8. Yeah. Okay, and the coefficient determination also higher. Yeah, so linear regression is better for this exam score prediction. Okay, yeah. Okay, then what else is yeah, just now when I did train the model here, I select the okay, yeah, here when you do the train the model here, then we use the okay, sorry, yeah, model explanation true. Okay, so let's see the output. Yeah, if we set the model explanation true, then what happened? Yeah, in here in the linear regression train the model, yeah, we double click. After that yeah, so we have the explanation, yeah, preview. Okay. Don't have train the model. Okay, yeah, so not providing. Okay, one maybe we have to. Okay, train the model. How about this one? Explanation. Okay, let's close, right click, view the log. Okay, it doesn't produce the explanation. Okay, everyone, so looks like not creating anything, eh? Now let's have a look at the okay, one moment. Yep. Okay, so in that case then that's the end of this milestone one. We already have added a few steps in comparing the different two more algorithm, and also change the target column, yeah, to predict the exam score instead of the sleep hours. Okay, so this you can put in the final project, yeah, that the data is not good or poor, yeah, to predict the sleep hours, but it's not bad, it's good, yeah, to predict the exam score. Okay, yeah, that's all. Let's take a break, maybe 15 minutes or 20 minutes, yeah. Then I will take your questions after this.